All right, we're going to continue with some multiplying. This time we're going to do the product of a two-term binomial times a trinomial. It's going to actually look like the monster claw. Take the 2x, multiply it times the first, then the second, then the third. 2x times x squared is 2x to the third power. Add your exponents. 2x times negative 6x is 12. X to the second power, adding exponents. 2x times 4 would be 8x. And I'm going to take the second term, which is a positive 3, and I'm going to multiply it times the first. That gives me 3x squared, and I think I'll align it with the other x squared term. 3x, or 3 times 6x, would be negative 18x minus 18x. And then I'm going to have 3 times 4, which is 12. Now, I need to combine like terms, and since I've aligned them, it makes it easier to see. There's only one that has 2x to the third. Negative 12 plus 3, that's like positive 3, would be negative 9x to the second. You only add the numbers in front. Negative 10x plus 12. So when I look for negative 10 plus 12, answer C is correct. What is correct factorization of? First thing I'm going to do is always look for GCF first. That is my rule of thumb. Look for GCF first. What number, what letters do they have in common that I could factor out? Well, I cannot take out a letter because they all don't have letter X, but they do have 2. I can factor out a 2. So if I factor out a 2, there's 1, 2, 3 terms, 1, 2, 3 terms in parentheses. The signs are probably going to stay the same. Divide out a 2. So if I divide out a 2, all right, 2 goes into 4x squared 2 times, and there's also an x squared there. 2 goes into 14, so it's basically like dividing out a 2. Now I'd have 7x left, and here I'd have minus 4. Now, if I look closely, I'm going to ask myself, is it possible that this trinomial can factor? I believe it can, because 2x and x is the only combination that multiplies to give you 2x squared. I'm going to try 4 times 1, and I'm going to put the 4 in the end. Remember to check. You're going to do inners. 1 times x is 1x. You're going to do outers. 2x times 4 is 8x. And if I subtract, and if the last term is negative, I am going to subtract, I could end up getting a 7x. In order to do that, I need my 1x to be negative, so I'll put a negative there, and I need a plus here. If I just bring my 2 down, this is my factorization, 2x minus 1, and then x plus 4. 2x minus 1 and x plus 4, C is correct. All right, number 27. I'll have to erase what I just did, so I'll have room for the next problem. 27, what's the factorization of this one? This time, they all have x. Remember, you're going to try to take out as many x's as you can. So it looks like I can only take out one x because that's all that they all have. So take out an x, 3 terms. So it's like subtracting an x away. The signs are going to stay the same. I'm going to have x squared. I'm going to have the 4 still and 1x because I took away 1. And I'm going to have minus 12. That trinomial will factor. What multiplies to give 12, that subtracts to give 4, would be 6 and 2. The bigger number wins the sign of the middle term, so 6 is the negative and 2 is the positive. So it's minus 6 plus 2, choice A. All right, for the next ones, they're not multiple choice, you just have to work them out yourself. I'm looking at number 28A, and I recognize it as a difference of squares. So that would be 2x times 2x. That would be 9y times 9y. Parentheses, 2x and 2x first and first in the parentheses. 9y and 9y. 1 plus, 1 minus. That's my answer. I did need to supply that answer. There was not multiple choice. In part B, it is a difference, but it's definitely not just squares. So I'm going to do the first thing I can. And the first thing is always to look for a GCF. Sure enough, if I check, 15 is divisible by both. And I can take out 2 C's and 3 D's. I take out as many letters of each that I can from both things. Then I'm going to put in here what's left. So it's like I'm dividing out 15 C squared D to the third. 15 goes into 15 once. C2 from C4 is C to the second. 15 goes into 105. think that's 7 times c to the second. From c to the seconds, no more c's, and d to the third subtracted from d to the fourth leaves me 1d. That is not factorable again, so I guess I'm finished after I do the GCF. 29. Factor. Now this is a trinomial, so I'm going to try to factor into 2 sets of parentheses, and I'm going to check the middle term. There's only one way to multiply and get 5x squared, and that's 5x times 1x. There's really only one way to get 2, and that's 1 times 2. I just need to be careful where I put the 1 and where I put the 2. If I put the 1 here and the 2 there, and I check inners and outers, remember this? I end up with 10x and 1x. When the last term's negative, I end up subtracting to get the middle term. That won't subtract to be 3. So 2 and 1 have to be used, so all I have to do now is to switch places with the 2 and the 1. So let's put the 2 in the, put the 2 in the front and move 1 to the back, and I believe I have it factored. This is 2x, this is 5x, and I need the bigger number to bench the middle term, so I need the 5 to be negative, which means I need the negative here and the plus here. Now, that check step is very important. We did that a lot. I hope that you do it. Take time to do it. That is your solution for 29A. 29B, I'm going to look for GCF first, just like we try to do. 3 will go into all the numbers. They all have at least 1x, and they all have 1y. So, if I factor it out, there are 3 terms, so I know I'm going to have 3 parts. 3 goes into 3. X from x is no x, except for 2 of them, and y from y is no y's. 3 goes into 30 10 times. X from x squared leaves me with 1x, and y from y is no more y's. 3 goes into 75 25 times, and there's no x and no y. Now this actually will factor again. I'm thinking what multiplies to give 25, and when the last term is positive, I'm going to add to get 10. It turns out that I need a positive 5 and a positive 5. Those 2 parentheses turn out to be exactly the same. There is a shortcut way of writing this answer. I can say that it would be 3xy times 1 set of parentheses with x plus 5 in it. Then I can say squared, because that tells me I have 2 parentheses just the same. If you wrote it out, or if you wrote it squared, either of those ways of showing the answer is correct. All right. 30. First thing I'm going to do is do GCF. And when I do, I know I can divide everything by 4. So everything will be 4 times smaller in number. I'm going to keep my signs the same. 4 goes into 4 one time with x squares left. 8 is left and an x. And I have 12. Does this trinomial factor again? Let's just see. Is there anything that multiplies to give 12? And because the last term is positive, it's going to add to be 8. I believe that's 6 and 2. You have to be a negative 6 and a negative 2. Bring your 4 down. This represents the complete factors of 30, all the way as factored as far as we can. All right, letter B. Let's factor letter B. First thing, GCF. There's a lot of these that have had GCF. Always check for that first. I believe I can factor out 3 and x. If I factor out 3 and take away an x, remember it's divide and subtract, plus, plus. I have 3 terms, so I'm going to have 3 parts inside. Remember, you're dividing out of 3x from everything. Divide out of 3x, divide out of 3x. You're going to divide and subtract. 4, x to the second, when you subtract x's, 3 goes into 15 5 times, there'll be 1x, and then 3x divided by 3x is a 1. Don't forget to put the 1. I think this may just factor again. 4 and x, and then 1 and 1, and I'm going to add to get the middle term, and that would be 1x, that would be 4x. Sure enough, it does add to get 5x, so it checks the middle term. So this one was factored twice, and now it's factored completely. 3x parentheses 4x plus 1. All right, my next part. We begin our unit 4 and 5. Some of these numbers of some of the problems might not match perfectly, but all of the items that you're going to check are the same as what you have on your review. Quadratic equation must contain each of the following. Well, by nature, quadratic implies x to the second must be there. Number 2, all of the following refer to the same thing except for which one? X-intercept solutions, constants, or zeros? Constants is not. We don't have a constant. X-intercept tells you where it crosses the x-axis, which is like solutions, and zeros. You also have another word. They're also called roots. So if you say roots, zeros, solutions, or x-intercepts, you're all talking about where it crosses the x-axis. So that's what I'm going to refresh with you on number 3, which one of these match. So when it talks about solutions, we're talking about where it crosses the x-axis. All right. Letter A only touches one spot, so that would match one solution. Letter B, notice it doesn't quite come up far enough to touch x at all. So this one does not touch x. Since it does not touch the x-axis, this one has 0 solutions. All right. And then the last one here, it actually touches at -2 and +2. So this one actually gives us 2 solutions. 2 x-intercepts, 2 roots, 2 zeros. Any of those phrases could be reused to the same thing.